Hi everyone, today our topic is the mean absolute deviation, or MAD. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But don't fast forward so much that you miss out on something important. All right, so what is MAD, or mean absolute deviation, you ask? The mean absolute deviation is exactly what it sounds like. It involves the mean, the average. If you remember from previous lessons, absolute is like the absolute value, so that talks about distance, because absolute value is the distance away from zero. So it involves the average, the distance, and then deviation just basically says how far away you're deviating or your distance is. So it's another kind of way to talk about distance. But remember, the absolute part tells you that it's going to be a positive value every time because distance is always positive. So that's all that means. We're talking about the distance away from the average. So the mean absolute deviation is the average distance between each data score and the mean. So the MAD, by using this calculation, tells us how spread out our data scores are. Because once we figure out the mean or the average, and we figure out how far away each data score is away from the average, it'll tell us how spread out the data scores are. Like if they're super close to the mean, the average, then that means they're not very spread out. They're kind of clumped together. But if all the data scores are like kind of close and others are really far apart from the mean or the average, then that means they're pretty spread out. So that's what the MAD tells us. So again, if it's a small MAD value, that means every data score is pretty close to the mean. So the data is not very spread out because they have a small deviation, small distance from the average. If the MAD value is a big value, a large MAD value, that means that those distances are really big. That's where we got the big MAD value from. So if the distances are huge, that means all the data is pretty spread out. So if you look at the blue, this is what it kind of looks like if you have a large MAD value. Everybody has a pretty big distance away from the average. You might want to use some colors in your notes as you take down these notes, but be sure you have the definition. And this little graphic is very helpful to let you know what your MAD even means to you. Okay, so there are 3 steps to figuring out the mean absolute value. The first step is to find the mean of the data, the average. And you should remember that in order to do that, you have to add up all the values and divide by your total data scores. That's how to find the mean. The second step is to find the absolute deviations. So you're figuring out how far away each of the data scores are from the mean. So you'll notice the absolute value signs around those differences. What that basically means is that all your values are going to be positive. So you're going to subtract the mean from each data score and just make sure if it comes out negative, you're going to switch it to positive because absolute values or absolute deviations tell you the distance, and distance is always positive. So what I like to do is just take the smaller number away from the bigger number. That way it's always going to be positive. And the last step is to now find the mean of these numbers. So you're going to do mean another time, except you're going to use your distances, not your original values. So you do mean twice. You're going to find the mean, then find the distances, and then you're going to find the mean of the distances. And then you're going to get a value. So for this example, it's 3.5. So that's considered actually a pretty big MAD. And if you look up there, you'll see that they are pretty spread out. The smallest value is 2 and the largest value is 12. The distance between 2 and 12 is actually pretty big. So that's what we mean by having a large mad value. A small mad value would be like closer to 1. Okay, so be sure to jot down these steps. We are going to go over some examples so that you can see it in action. So here is another problem where you are asked to find the mean absolute deviation. Go ahead and pause the video and try it on your own. All right, so we're gonna put up those steps up here first. Let me move it over here. So first thing is you have to find the mean, then you have to find the absolute deviations. Remember, they're always positive. And then lastly, you're going to find the means of those absolute deviations. Okay, also going to be a positive number. So first step is I need these numbers. Each of these is 2, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 2, 4, 2, 4, 6, 8. All right, so I need to find the mean first. 8 plus 12 plus 4 plus 8. Take that, divide it by 4. So first I'm going to find that sum. 8 plus 12 plus 4 plus 8. That'll give me 32. 32 divided by 4 is 8. All right, so we figured out the mean. And then the next step is to figure out the absolute deviations. That's the distances. So each of these numbers, we have to figure out how far away they are from the mean. The first number is 8. So 8 is 0 spots away from the mean because it's already the mean. 12 is 4 spots away. I can subtract those. 4, and I'm just going to switch it, is 4 steps away as well. It's just on the other side. And then we have another 8, which is also 0. So here are our absolute deviations. We're just going to be using these numbers from now on to figure out the mean again. So we're going to take these numbers, add them up, and then divide by 4 again. So I get 8 divided by 4, 2. All right, let's try one last problem to work together, a mean absolute deviation. Same question, they want to know the mean absolute deviation, but for this data set now. Pause the video and try it on your own first. Okay, so the Alstons ran a family relay race, and these are the distances that each of the 6 family members ran in kilometers. You can already tell these numbers are pretty close together. So let's see what happens when we figure out the mean absolute deviation. So first step, as always, is to figure out the normal mean. That's going to be to take all those numbers and to add them all together. After you add them all together, divide by how many? There's 2, 4, 6. So let's see, I'm going to need my calculator for that. 0.3 plus 0.6 plus 0.5 plus 1 plus 0.4 plus 0.8. So that adds up to 3.6 divided by 6. 3.6 divided by 6 is 0.6. So that's the mean. Then we have to figure out the absolute deviations. Those are all positive, and we want to figure out the distance. Each of them are away from 0.6. So 0.6 is, after the subtraction, 0.3 steps away from 0.3. 0.6 is 0 steps away from 0.6. It's the same number. 0.6 is 0.1 steps away from 0.6, or sorry, 0.5. And for 1, it's 0.4 steps away. 0.4 is 0.2 steps away. So I'm just doing subtraction. I'm taking the bigger number and subtracting the smaller number, so I can always get a positive answer. And the last one is also 0.2, just in the opposite direction. Here are all our new numbers that we're going to use to figure out the mean again. So repeat the process up here, but with these numbers now. Careful, they look a lot alike. So this is the mean for the absolute deviation, the new numbers up there. 0.3 plus 0 plus 0.1 plus 0.4 plus 0.2 plus 0.2 divided by 6, because there's still 6 numbers. This is 0.2. I'm going to make sure I write that correctly, or it looks like 0.7. 0.3 plus 0 plus 0.1 plus 0.4 plus 0.2 plus 0.2. That's 1.2 divided by 6. 1.2 divided by 6 is not 2, it is 0.2. Let me see if I can put that up here. This is the mean absolute deviation, 0.2. Our previous answer, the mean absolute deviation, was 2. We had a lot of spread compared to this one here. This one, if we were to put them all on a line for all those numbers, they would be pretty clumped together, because these are all decimals here. So they would all be like clumped very close together. Okay, so that's why that mean absolute deviation is super tiny. So that means that your numbers are not very spread out. All right, so that's an example of one that is more spread out and one that's less spread out, this one right here. Let me know if you have any questions as you work on these problems, and I'll see you in class.